go far, we need to know what we need to achieve today. We need to achieve two things. Please don't end the lesson without achieving the two. Okay? The first one is going to be, by the time this lesson ends, the learner should be able to achieve two things. One, should be able to define a mole. Two, determine the molar mass. Determine the formula mass or molecular mass. Those are our two objectives. I would request the producer to also display them so that we emphasize those objectives. I want my learners to be attentive following those objectives. That is going to be our major aim today. Okay, mole concept is not new. Some of you have been applying this concept in different aspects of life. You have been involving it in so many things. You have been applying it in day-to-day life, but when you don't know. So today I want to bring it to your understanding that this is mole concept and this is how you have been applying it. You get to know, you get to appreciate, and learn as well. As you learn, I want us to first have a video so that we start with what you know and we get to know what you don't know, right? I'd request my producer to play for me that video for my learners.
By things using standard values. In other words, we always take 1 kilogram of rice or 200 milliliters of fruit juice. Fruits are sometimes counted using the unit dozen. 1 dozen means 12 of something. These are terms used in everyday life. But what if I want to measure something in terms of the number of tiny particles present in it? Let me explain this in detail. Looking at this pure gold, can you tell me how many gold atoms are present in this? Or wait, looking at this glass of water, can you tell me how many water molecules are present in it? You will probably say that it's practically impossible to calculate the number of atoms or molecules in these examples. But astonishingly, chemistry has an answer to this as well. That brings us to the concept of...
I think you have had a look at those things. So we are going now to dig deep into this concept. We are going to start with what is mole concept. From what we have seen, what is mole concept? Okay? Mole concept, what is it? We are going to see that mole concept majorly deals with determining or counting the number of particles. Okay? As you count the number of particles, you get to realize that there are so many particles in a given substance. Okay? So when you look at these particles in details, you'll find that there are many. Take an example of what we have just seen. We have just seen 1 kilogram of posho. Okay? Some of you say that, give me 1 kilogram of posho. But this 1 kilogram of posho, you don't know how many posho particles are there. So today we want to use that one as our example to go into details of chemistry concepts. Okay? So posho, when we say posho, we don't know. Even if I have just small portion in my hands, I will say that is posho. Even if I have 1 kilogram, I will say that is partial. Then if I have a full sack, I will say that is partial. So that's what we are going to look at. So since these particles have been identified to be in large numbers, so chemists came up with a formula and said that now you see what? We need to group them, okay? So these particles have been placed into groups, and these groups are called moles, okay? The group names are, you say this group is called a mole, all right? So a mole, if I'm to group partial and say 1 kilogram, what do I expect in 1 kilogram? How many particles do I expect to be in 1 kilogram of partial, all right? So if I say a mole, how many particles do I expect to be in that group? Have a look. That one mole will be with 6.02 times 10 power 23 particles. Okay? Those are the number of particles we expect to be in 1 mole, right? This one, 23, it looks like a big figure, but some of you may not understand it. Let us first use a smaller figure as compared to that one, so that you'll be able to take the concept. So when we say this one, power that one, that means this one will mean 6, 0, 2, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, up to 23, okay? Let us put it here and it becomes clear. 6, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 22, 23. That will be the figure being represented by 6.02 times 10 power 23. Okay? You can see how big it can be if we decide to write it like this. Right? So these are the number of particles that are grouped in 1 mole. All right? Once we say 1 mole, we are meaning this number of particles. Okay? What are these particles, if we can ask ourselves? What are the particles we are trying to group? Okay? The particles we are talking about molecules. That is also part of the particles. We are talking about atoms. We have ions. We have ions. We have protons. We have electrons. And many more specified particles that you may come across. These are the particles we have. Okay? So these ones, we can take examples from what we have said. We have said that 1 mole represents these particles. Okay? 1 mole represents those particles. Producer, if you can give me slide 9 and we look at the examples of these particles. Okay? on that slide, you can look at these ones being expressed in the number of particles. You look at a group. If now we just pick a portion of magnesium atoms, okay? We say 1 mole of magnesium atoms contain 6.02 times 10 power 23 particles, okay? Just 1 mole contains those particles. Also, when we go to magnesium ions, we realize that also when we say just 1 mole of magnesium ions, 1 group of magnesium ions will contain those particles. Okay, let's go back to the market. You can use, that is the market language. You say, I need 1 kilogram of posho. But that 1 kilogram of posho, my dear, to be having, it is just a group. You're just having that kilogram. You're using the word kilogram as to mean the group. That group is having very many particles of posho, and you had not realized that one. When you go and say, I want to buy 5 tomatoes, okay? So you may say that I want to buy 1 mole of tomatoes. But in the market language, you're trying to use the chemistry concept and say, it is just a password in your market. You know, in different areas, they use different passwords to mean different things. You can say, I want 1 mole of tomatoes, meaning that you want to buy 5 tomatoes, okay? You can say, I want 2 moles of oranges. That means, for you, as when he says he wants 2 moles of oranges, that means is meaning that you want 10 oranges. That's what we are trying to mean here. That when I say 1 mole of magnesium atoms, I'm meaning that someone is referring to 6.02 times 10 power 23 particles. Okay? That's why we say that when they were considered, if you are to count these ones, you start counting 1 by 1, 1 by 1. How many days will you take to reach this number? Okay? You take so many days to reach this number. But when you say you decide to group them and use just 1 mole, you'll be counting moles. You say, I just need 5 moles. That means 5 will be times this one. And you find you have very many particles at once. Okay? So when we look at the second part, on the same slide, we have looked at atoms. We have looked at ions. Now at least let us also look at molecules, because here we have listed a number of things. We have listed molecules, atoms, ions, protons, electrons, and many more. But now we have looked at an example on ions, atoms, molecules. Okay? So when you go to the lab and you say, I need 1 mole of sulfuric acid, okay? That means in that 1 mole of sulfuric acid, you're trying to mean that you need 6.02 times 10 power 23 particles of sulfuric acid. Okay? That's what you mean. So that is the concept behind 1 mole, that 6.02 times 10 power 23 particles. That's what the scientists tried to mean. So having looked at all this one, we have tried to see a mole concept referring to the determining or counting of the number of particles, and we have realized that particles are very many. We need to group them, and the group should be a mole. Chemical definitions, most cases, you need to develop your own definition. You look at what you have been studying and say, what is this now? Okay? You come up with a definition. All right? So having looked at all that, we can now look at what is a mole. Okay? What is a mole? Okay? What is a mole? We have seen so many things. Okay? Scratch your head. It is a behavior to scratch your head. It is normal. Okay, some people think very fast when they touch into their head. Okay, or some of you can shake your heads and you get the answer. But from what we have seen, we have come to know that a mole is the amount of substance containing 6.02 times 10 power 23 particles. Isn't it what we have been looking at? We have been looking at exactly that one. So we have developed our definition from what we have been looking at. So you cannot forget a definition for a mole if you have been following very well. That a definition for a mole just comes from, just you look at 1 mole equaling to 6.02 times 10 power 23. Then you just get a definition that is the amount of substance containing 6.02 particle times 10 power 23 particles. Okay? So, in most cases, when you read different textbooks, you'll meet different definitions, but you may find they are all correct. Please, if you're a student there and you come up with a given definition, consult your teachers, consult someone at least who you might be knowing at least better concepts in chemistry, or has studied chemistry, maybe is in A level and you're in senior 2. You can consult that person, because if a person passes chemistry, meaning that at least he understands something in it, so he can be able to guide you. Or if not, you read textbooks. Some of you at home use your phones. Don't go on Facebook and WhatsApp and waste time. Just keep on internet, Google some of these things, and you get a bigger picture of them. Okay? So another definition you can look at. Producer, I would request you to give me slide 10, and we look at the second definition of a mole. Okay? That is the second definition, where is the word all. Just a mole is the amount of substance that contains the same number of particles as the number of particles in 12 grams of carbon. Okay? We are looking at a mole having the same number of particles as those ones in 12 grams of carbon 12. Okay? That's what the definition is talking about. Okay? That if you want to know how much can be a mole in terms of grams, you just refer it to 12 grams of carbon 12, and you get the amount of a mole. So this mole, who came up with this one? Was it a group? Was it just from anywhere and we came to find it in books? But or it was out of someone's effort? So someone had to read chemistry, analyzed it, and came up with this concept, and that was Avogadro. And now that's why it has been termed to be Avogadro's number, or Avogadro's constant. Okay? And it has been denoted to be letter L, capital L. Capital L or NA. When you read different textbooks, you'll find they refer it to capital L or NA. So this number, you don't need to stretch yourself with it. Sometimes it is provided. It is always provided in standard papers. You find it there, either on the first page or within the question. You'll find it there, put in brackets. If you see L equaling to 6.02, that times 10 power 23, that means they are referring to Avogadro's number, and you need to use it in that question. So if you are calculating a question and realize that that question is involving moles, then you should go back to the first page and see, okay, 1 mole equals what? All right? And you get to know it in case you forget. But I don't expect my students to forget today. This one is going to stick to their heads, and they will remain with it. Okay? So when we move on, we have seen a mole, we have seen what it means, and we have defined it as well. And we have got to know who came up with this number, who grouped these particles. Okay? So after knowing who grouped the particles, let us go to molar mass. Molar mass. We have seen a mole. Now, what is molar mass? We are going to see what is molar mass. Molar mass is the mass of 1 mole of a substance. Okay? Molar mass is the mass of 1 mole of a substance. Remember, we have just said that a mole can be defined as the number of the substance containing equal number of particles as those number of particles in the 12 grams of carbon 12. Okay? So if we are looking at grams, now we want to go on and calculate and see how can we determine the molar mass. Okay? But before we determine that, we want to see what is it? What is molar mass itself? Okay? Molar mass is the mass of 1 mole of a substance. Okay? Is the mass of 1 mole of a substance. And this one is equal to the relative atomic mass. Okay? Expressed in grams. When you put the relative atomic mass in grams, you realize that that one is exactly the molar mass. Okay? And in most cases, some of you have been using this one. You have studied about relative atomic mass or relative atomic number of different elements, okay, or different atoms, right? So you have studied them. That is the exact number. You just need to include their gram. Okay? Let us have a look when you go to our slide 12. We have a look at those relative atomic masses that have been already established. Okay? Producer, give me slide 12. Yeah, that is the slide. So let us have a look at it. When you look at hydrogen there, you realize that hydrogen has the relative atomic number 1, okay, or relative atomic mass of 1. Okay, so in the molar, when we say what is its molar mass, it is 1 gram. The relative atomic number is 1. The molar mass is 1 gram. Look at carbon, it is 12. Carbon is 12, has the atomic number 12. So the molar mass is 12 grams. Okay? Sodium, 23. That means that you just add there gram and you get the molar mass. Copper is 64. You just add there gram and you get the molar mass. The next slide, we also look at other elements. For example, chlorine. Chlorine is 35.5. Okay? Let's go to the next slide. Next slide, we look at chlorine, which is 35.5. Okay? And that means if it is 35.5, the grams are going to be 35.5 gram. That is the molar mass. Okay? When you go to iron, iron is 56. Atomic number of iron is 56. That means the molar mass is 56 grams. All right? Hopefully that one is going to be difficult for all of us. Okay? Let us go to the next slide and look at what they call formula mass. We have seen the molar mass. Now we are going to formula mass. Okay? We are going to formula mass. What is formula mass? Because we have seen the molar mass. Molar mass, we have said, is the mass of 1 mole of a substance. Now, what is formula mass? Formula mass is the mass of 1 mole of a compound. Is the mass of 1 mole of a compound. Okay? This one is talking about a substance, and this one is talking about a compound. But you would ask yourself, what is a compound? Okay? In senior 1 or senior 2, depending on the coverage you took in those classes, depending on the teacher, what he wanted, but I assume that you all studied a compound in senior 1 or senior 2 first term. All right? So when you go to formula mass and you go to the mass of 1 mole of a compound, we have to define a compound. Okay? A compound is a mixture of 2 or more substances chemically combined. Okay? So here it is only 1 substance. Okay? Because it is a substance, meaning 1. But here a compound, meaning that they might be 2 or 3, but they are chemically combined. Okay? So that's what we are going to look at. This one was just given from, you just state from, you pick from what you see as relative atomic mass, you give it as the molar mass, but you add there just the word gram. Here, it is the mass of 1 mole of a compound, and we are saying that a compound is a mixture of 2 or more substances chemically combined together. So we are going to see how do we calculate for formula mass. If the other one was, we were just stating with the addition of gram. Here, we get the formula mass by combining all the relative atomic masses of the elements present. Okay? We combine all the relative atomic masses of the elements present. You know, when you talk without doing it, someone may not understand what are you meaning when you say combining all the relative atomic masses of the elements or substances present. Okay? Because it is a mixture of substances. At each substance, you say this substance, I add there this one, I add there this one, and I get the formula mass, because it is the total. Okay? So let us look at the first example on slide 15. Let us look at that first example. Students, look at the example and you think about it. Okay? It is saying calculate the formula mass of water. Calculate the formula mass of water. What do I expect? When I say calculate the formula mass of water, what do I expect? There are few things that I expect. We calculate together. The question is about formula mass of water. You write water there. What is the chemical formula? What is the chemical formula of water? Water is H2O. We all know that one. Is it hard? It's very simple. That is water. Okay? We are together. Please make sure the calculator is next to you because you are going to do some additions. Okay? Don't need to stress yourself with this. Just need to use your calculator very well. So having known this one, now we get back. In a standard paper, you'll turn at the end, and you find there the periodic table. And this periodic table is always having elements with their relative atomic masses. Okay? Relative atomic masses. When you meet there, you meet an element there, and they say here there is the atomic mass. Okay? And here you find, here is atomic number, and here atomic mass. Okay? What do you need? You need the atomic mass from that. All right? You don't need the atomic number. Okay? So when you go to atomic mass, you see in other questions might put this in bracket and say hydrogen 1, oxygen 16. Okay? That is it. So here we are going to calculate this. Having identified that one and having seen that water is having hydrogen and oxygen, then we come here and say how many atoms of hydrogen do we have? We have 2 times hydrogen atom plus we have 2 atoms of hydrogen. Okay? How many atoms of water do we have? We have 1 times the oxygen. Okay? The atoms of oxygen you have 1, atoms of hydrogen you have 2. So here we put in figures. From here we say hydrogen is 1 plus water, oxygen is 16. Then we say 2 plus 16. The answer we get 18, and you put there grams. Since we said that anything involving mass means that it is going into grams. Okay? So that is how we calculate we determine the formula mass in this. Okay? It is very simple. We need to begin with simple examples as we go on building the idea. We shall start from simple, and at the end we shall look at complex numbers. Okay? This was our first example. Hopefully you have been moving with me and you have dotted it down. Okay? So we can go to example 2. Can look at the example 2. Producer, give me example 2 on slide 17. That is our example 2. It is saying calculate the formula mass of oxygen molecule. Okay? I've just seen water. Now we are going to oxygen molecule. We have said that when you are going to attempt this number, you first identify what has been asked. They want oxygen molecule. What do they mean by oxygen molecule? Remember, we have oxygen molecule as well. We have oxygen atom. So oxygen molecule is O2. Okay? O2. And the next step, you say O2. You put it there and you say what is here. This is a compound, or this is a molecule. Okay? Because it is having 2 atoms, 2 substances, but similar. Okay? Put in bracket oxygen equaling to 16. This one you pick it from the last page of a standard paper, from the periodic table. Pick there 16. After putting it there, you come here and say how many atoms of oxygen are there. This number is representing the number of atoms. It is 2 times the oxygen atoms. Okay? After writing that one, what next? You go to 2 times the oxygen, which is 16. Now you come up with your answer, which is 32 grams. That means the formula mass of oxygen molecule is 32 grams. Okay? That is it. It is very simple, involving few steps, but you need to be accurate. Okay? And you need to write well. Okay? Let's go to example 3. When you look at example 3, okay? When you look at example 3 on slide 19, we look at it saying that calculate the formula mass of sodium sulfate. Example 3. It is involving sodium sulfate. Okay? Example 3, we are looking at sodium sulfate. Okay? We have said that the first thing you do, you identify what has been asked. In this question, they have asked us to calculate the formula mass of sodium sulfate, and that's what we are going to do. It's going to be simple, and everyone is going to enjoy it. Okay, this one is a bit complex as compared to the previous example. Okay? Though before you attempt to this one, you have to first find the chemical formula of this compound. What is the chemical formula of this compound? Let me take you back to lower secondary, lower class, that is senior 1 and 2, chemistry. Because I know some of you may be in Form 4, some of you may be in Form 3, and you are not remembering this work. Or you studied it, maybe you took it to be just maybe this is senior 1 work, but now we want to see how we can apply this work also in today's lesson. Okay? When you are given sodium, and here you are given sulfate, okay, and you want to write the formula, chemical formula. Chemical formula of this one is 1, you identify the elements present or the radicals present. We have sodium, and here we have a sulfate as the radical. Okay? We want to write the chemical formula of this. The next step is you give them the valences. Sodium is valence 1, sulfate is valence, has a valence of 2. Sulfate radical has a valence of 2. And we all studied valences. Okay? So we have principles governing this. We said that when the valences are the same, we cancel them out and rate elements close to one another. But when you look at this one, valences are not the same. We said that if the valences are having the common factor, we divide by that common factor, and then we rate elements close to one another. When valences are not the same and they are not having a common factor, we interchange them and rate elements close to one another. And we don't interchange from here. That one becomes another step. Two, you interchange, this one comes here, and this one goes there. And you rate them close to one another. In chemistry, when I put here 1, just like a repetition, everyone can see that this is 1. Okay? So when I get one, I say this is an orange. Okay? And I say it is one orange. That means I will be repeating myself. Just everyone can see that it is one orange. So here, if it is like this one, we just leave it and say it is Na2SO4. That means that one becomes the chemical formula of sodium sulfate. Then we put it here. Sodium sulfate is that one. Once you have this one, you are sure that you have done the number. Because once you fail to get this one, the number is not going to be correct. You're going to get a different value. All right? So the second step, you write this one here. Sodium sulfate. And you go to your periodic table and pick atomic masses of the elements present. All right? You say there is sodium and it is 23. I've picked it from there. Okay? You say there is sulfur and it is 32. I've picked it from there. You say there is oxygen and it is 16 and I've picked it from there. All right? Now you go to another step. You have seen that one. Then you say atoms present. You start by saying there are 2 atoms of sodium plus sulfur. It is 1 times the atom of sulfur plus, you can use brackets here. Okay? You say oxygen, there are 4 times the oxygen atoms. All right? That is it. Then you will substitute to put their figures. That is 2 times the 23 plus 1 times the 32 plus 4 times the 16. Okay? Can we use our calculators now? And we multiply 2 times 23, get 46, plus 1 times 32, we get 32, plus 4 times 16, we get 64. What is going to be our answer? Please put there the answer. We get 142 grams. And that is going to be our answer. That's going to be the formula mass of sodium sulfate. Okay? That is the formula mass of sodium sulfate. Please, if you have got a wrong answer, try to use your calculator very well. And you make sure you come up with 142 grams. That was our example 3. So you can look at the last example, but not least, which is example 4. On slide 21, producer, example 4, calculate the sulfate crystals. Calculate the formula mass of copper 2 sulfate crystals. Okay? I think we are done with this. Can take it off. Example 4 is saying copper to sulfate crystals. Okay? The word crystal means that there is water in this compound. Okay? The word crystal means that there is water in this compound. And when you follow the steps you have been using there, you come up with a formula mass of this. But before you follow those steps, you have to make sure that you first determine its chemical formula. And you have to follow the steps for determining the chemical formula as given above. Okay? And you come up with what is called CuS4.5 water. Okay? That is the chemical formula of copper 2 sulfate crystals. This is not new. Most of you have been looking at it. You have seen it in water as a topic, water and its compounds. You have seen it is there when you carry out a test for water using anhydrous copper 2 sulfate. You come up with a crystal, and this is the crystal. And for that case, let us go straight to determining the chemical formula. Determining the formula mass, since the chemical formula is already here with us. Okay? So we said we first write the chemical formula here and say that is the chemical formula. After writing it, we go to our periodic table. Okay? Go to our periodic table and we pick the relative atomic masses of these elements present. Remember, we have copper, we have sulfur, we have oxygen, we have hydrogen. So we say when you go there, you find copper is 64. Go there and find sulfur is 32. Oxygen is 16. Hydrogen is 1. Okay? That one, you don't need to put these things in your head. In a standard paper, they will always be there. Okay? But the simple ones like oxygen, hydrogen, sulfur, you can put them there. Though when you meet elements like iron, cobalt, those ones you will always find them there. Don't stress yourself. Okay? Just learn the basics. Other things are going to be simple. Okay? So having got that one, you come here and say, how many atoms of copper do I have? It is 1 times it is 1 atom of copper. Say plus 1 times 1 atom of sulfur plus, okay, 4 times oxygen. That means you have 4 atoms of oxygen plus 5. This 5 affects everything here. It affects water. That means there are 5 molecules of water. So what you do, you put a big bracket and you say, within there you say it is 1 times 2 plus 1 times 16. It is 1 times we are still following the formula, the symbols, oxygen. The next step we shall put there the numbers. Okay? So after getting that one, we now substitute. We say 1 times 64 plus 1 times 32 plus 4 times 16 plus 5 into 1 times 2, it is 2. 1 times 2 plus 1 times 16. Okay? Here we get 1 times 64. Let us use our calculators very well. Let us use our calculators. 1 times 16, 64, we get 64, plus 1 times 32, get 32, plus 4 times 16, get 64, plus 5 into 2 plus 16. Okay? I need you to follow that step and you come up with the answer. Okay? I need you to follow that step and you come up with the answer. Do it there. Okay? Just need to add up 64 plus 32 plus 64 plus 5 in brackets 2 plus 16. Okay, hopefully you have come up with the answer, which is 250 grams. Okay, 250 grams. With that, I think we are done with the examples. Now what next? Okay, remember my work is to make sure that we share. Okay, then you do. Right? So let us go to our exercise. I would request my producer to display the exercise for everyone. Okay? On the slide, display the exercise. Okay? Our exercise is saying calculate the relative formula masses of the following compounds. Okay? Of the following compounds. Calculate the relative formula masses of the following compounds. And those compounds have been able to put for you the relative atomic masses in the brackets. That means your work has been towards aluminium oxide to make it be hard for you to calculate it, but I've made it be simple. In a simple way, calculate the relative formula masses of the following compounds. When we meet again, we are going to start from there and look at those numbers and see the answers we got. But before we end the lesson, I would like to remind you that go onto our website, which is our website is www.codehighschool.sc.ug. Okay? When you go there, make sure you log in. First create the account. After creating the account, log in. After logging in, you be able to access the work. We shall be meeting same time, different concepts from 6 a.m. to 8 a.m. Don't miss. If you miss today, don't miss tomorrow. If you attended today, come early tomorrow. Attend in person, invite a friend, invite your colleagues. Let's learn together. Thank you.
Television, your family.